Alrighty, good evening, good afternoon, or good morning, whatever time you happen to be watching this at. This is a second go around. I was doing this lab earlier and I was clearly half asleep during the process, so I wanted to redo this so that way it was clear and you didn't have to deal with me forgetting how to do things for 20 minutes. So this week's lab is actually pretty straightforward. It's two switches, switch 1, switch 2. We need to create 1, 2, 3, 4, 5, 6 different networks. Pretty straightforward there. We're using variable length subnet masks. That's VLSM subnet scheme. We're configuring this. Interestingly enough, we're using 3 straight-throughs. If we wanted to follow the quote-unquote proper process, not utilizing auto-sensing ports, the link between our 2 routers would actually be a cross-through cable, not a straight-through cable. But all of these are Ethernet connections. It's not utilizing a serial connection like we've seen in the past. Or actually, I don't even know if we've actually used a serial connection between routers yet or not, but nonetheless, it's not actually utilizing that, so that's fine. 2 routers, 2 switches. It says Ethernet and serial cable as shown, but we're not actually utilizing any serial cable, so we don't have to worry about that. We're connecting the gigabit Ethernet interfaces between the 2 routers and the gigabit to a fast Ethernet, and they've defined which ports we're using there. 3 of the VLANs are going to be for future use and not for current use, so we really only are utilizing 3 of the networks at the moment. We have some review questions about how many hosts and subnets are available, and then we have questions specifically about that. The largest subnet, the second largest subnet, the third largest subnet, and the fourth largest subnet questions. We have a little table here to fill in based on the IP address that we were provided with, which was the 192.168.33.128/25. Normally, when you're going through subnetting of this, one other thing you'd actually want to look at is, as an example, if our gateway out to the cloud, so to speak, was coming off of this BR1 router, then obviously we want to have the 40 hosts subnetting one way. But then everything else we would want to have subnetted underneath one branch, so to speak. And the reason being is then we can sort of group these all into one larger supernet and then have one static route that would, transition its way out, so to speak. But in the case here, because both these routers are directly connected and they have all the networks on them, it's able to sort of get that routing information, so we can basically do our ping from one to the other. And if we want to make this a little bit more exciting, it doesn't actually make us, but we could actually go ahead and configure our switches with our VLANs. So it doesn't have that set up, but it's something we can definitely look at. And then here it gives us the addresses for our interfaces, so that kind of, I don't know, you'd almost say defeats the purpose of asking for the VLSM portion, but nonetheless, it's still something important to do. And then we need to cable it and configure it. So they have it grouped up into groupings. So the host name, we're getting rid of the domain lookup. So if you accidentally type something in the enable mode, it's not going to sit there for 5 minutes thinking about its life. We're setting our privilege mode password to class. Assigning Cisco. Yeah, so we're setting our line consoles. So we got our direct connection over our console cable password, and then we have our connection over TTY or VTTY. So our telnet. In this case here, it's 04, so we're only actually doing 5 remote connections. So 0 through 4. We're not doing that 0 through 15. We're applying the encryption using our service password encryption. Our message of the day, instead of using hashtags, we're using $signs as our delimiting character. We're going to go ahead and configure our IP addresses to our interfaces. We're also going to configure a description to each interface, and we're going to do the no shutdown to bring them online. Make this a little bit quicker. We're actually just going to sort of group these together, so it's easy enough just to open up the interface, apply an IP address, chuck a description on it, and then bring it online. Easy enough. And then we're going to copy our running config to startup. That way when we power down, the configuration will stay there, and then we can do our test ping. So doing a ping from the router, one router, to the other router, basically. Easy enough there. Pings to the gigabit Ethernet LAN, yeah, because it needs the routing information. Yeah, so we can ping 250, so we're just basically pinging across the link. And actually, I think it's probably a good idea. We can even talk about static addressing or static routes, so that way we can fix this. So yeah, there's actually it's a pretty short lab, but we can actually make this into a little bit more exciting of something. So before we start, the one thing I always like to do is I like to make my little cheater table. And this time when we make the cheater table, we're actually going to make it correctly without mistakes. That makes it a little bit easier to use if it's actually correct. So let's make our little table here. So we got our table. It's a class C, so that actually, as I've always said, that makes this really easy because we only need to deal with 8 bits of information. Okay, we got that. So we got our binary. Then we got our usable hosts, usable subnets, subnet mask, and why not? Let's add in our CIDR notation. Clean this table up a little bit. Cool. Okay. And let's put in our columns. So we need to split this into 8. So we got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Good enough for us. So let's put our binaries in. So we got, let's actually switch this color because it's going to get really messy if we don't. So let's go to a nice blue. 1, 2, 4, 8, 16, 32, 64, and 128. So we talked about this before. Usable hosts. Usable hosts come from the right. Subnets borrow from the left. And then we got our mask and our CIDR notation. And if we recall our formulas we can use, our formula for usable hosts is 2 to the n minus 2. Our formula for subnets, so this is for hosts. For subnets, it's just 2 to the n. So if we're going through that, what's going to end up happening here is we actually don't have anything usable. And then we can go ahead, let's pick a different color for the usable hosts. So usable host, we can kind of just look at our binary and drop down by 2. So that's 4. That one is going to be 6 from 8. This is going to be 14, 30, 62, 126, and this is 254. And if we borrow from subnets, we basically just go the opposite way. So it's 2, 4, 8, 16, 32, and then 64. Because we can't borrow this, because if we do, then we're not going to have enough available. So, nay, nay. And then when we're talking about our subnet mask, it's simply just by adding these up from this side. So when we do that, we're going to add up that, and then we're going to add it to that, and then add it to that, and then continue down until we get to the last subnet, which is this. So our subnets cannot extend past this point. So we need to have at least 2 host bits. And this is our 4th octet that we're dealing with. So our mask is 128. 128 plus 64 is 192, right? Because 120 plus 60 is 180. 8 plus 4 is 12. 180 plus 12 is 192. We got 192 plus 32 is 224. 224 plus 16 is 240. 240 plus 8 is 248. And 252. And then we can't do this, and we can't do that. And our CIDR notation, this would be a /25. Here, let's use another color to keep with this rhythm. Let's go brown. So that is a /25, /26, /27, /28, /29, and /30. NA, NA. Nada, can't do those last ones. So that's kind of what we end up with now. So what we're given as our starting out point is we were given a address of 192.168.33.128, and we were given a notation of a 25. So notation of 25, if we look at our chart, we see here that that represents that we're basically starting out, and let me grab a nice neon color to make this obvious. We'll go neon orange. Why not? And I think I'm using a pen right now, so let's go with something nice and fat that we can make it obvious. So what I'm doing right now is I'm just highlighting out and showing what we have. So that bit there, that bit we can't really do anything with. And the reason why we can't do anything with it is because it was a ballpoint pen that I was using before. That's always going to be at least a 1. Nothing's going to change there. This bit is always going to be flagged as a 1. And the reason being is because we've been given in a range, basically, of 25. Our magic number that we increment by is going to be our 128, basically. So our next one after that would be 256. So if we went up to the next, then that would be our next point. So we weren't given the full classful range of /24. We were just given a small subset of it, which was a /25. So we were given access to address 128 through to through 255, basically. Obviously, we can't use the first address, and we can't use, actually, technically, it'd be 256. We can't use the first address, and we can't use the last address, which is 255, because of the whole broadcast bit. So what we end up needing to do, and I guess I should actually just say it's 255 for the sake of it, but anyway, so that's our range that we get to work with. So let's take that off. Let's go get my snipping tool, copy over the bit that we're working with. Snip, snip, snip. Perfect. Got that there. So that's what we get to work with. We have a little bit of stuff there. So let's put that there like that. And I think they gave us a nice little table. So let's just copy that table. It's going to make it easier, and I don't have to then draw out this table again. Because that's also kind of annoying as well. I had that problem on the last recording. The pain of drawing out a table and then making everything legible. Let's make this a little bit bigger. Bang. Just like that. See? Easy peasy. Okay, so we need to give 40 hosts to this one. We need 25 hosts to that one. And then we have 3 that we have for the future, and then we have this one that we need 2 for. Easy enough. So usually what I actually like to do when I have a bunch of numbers is we can kind of look at, yes, we have what they're asking for, but the question really becomes, what do we actually have to give them? So when we're looking at the number of hosts needed, it says that we need 40 hosts as an example. Well, 40 hosts, if we're starting out at a /25 and we have 128, 40 hosts is actually going to make us need a let's see, if we shift this over, /26, because that's going to provide us then with 62 hosts for that subnet. So we need to actually give it 64. And the reason why I say 64 is because, yes, it's 62 hosts we're giving. We can't use 2 of them, but the block is incrementing it by 64. So 2 of them are unusable, but I'll just write 64. For the 25, we do need to go above the /29, because /29 is going to give us 6. /28 is going to give us 14. /27 is going to give us 30. So the number of hosts needed is technically 32. We can't use 2 of the number because we have that formula. It's basically 2 to the n minus 2. And that's because the first one is for the network and the last one is for the broadcast. It's 32, and then we got 5. So if we make this a /29, that's going to give us 6. So that gives us 8 addresses that we're giving. This one here, same thing. Unfortunately, we do have to give it 8 because 2 is too little, which would be a /30, so it's a /29. 8, and the last one here, it needs 2, so we can give it a block of 4 addresses because we lose 2 of them, so that's fine. So next up, we need to do the little bit of networking. So what ends up happening is, I'm just going to shift this up a little bit. We'll fill a table in a second, but I think it's going to be a little bit easier if we do this below the table and then fill it up in afterwards. Okay, so let me get the address that we're starting out at. It was 128. All right, so I'm just going to put a little number next to these. So that's number 1 that we're working with, that's number 2, that's number 3, that's number 4, that's number 5, and that's number 6. Just to make this a little bit easier. All right, so yellow's a really terrible color to use. Let's pick something different. Light mahogany. Cool. Okay, so number one, we need to give it 64 hosts. And we're starting out at 128. And what's our thing? So if we need to give it 64, it means we're making it a /26. It's going to give our mask of 192. Okay. So it starts at 128, and it needs to increment by 64. Well, it's 128 plus 64. It should be pretty easy by now, hopefully, which is 192. So 128 to 192, and it is a what did I say it was? /26. Ooh, that was exciting there. /26. And I think actually in one of the things, if I remember correctly from about an hour ago, it actually uses, for whatever reason, in the answers, it said it was a /25 that was referenced, but it's not. It's actually a /26. And that thing, we ended up taking some time. I went through it and I double-checked everything. Even though I couldn't seem to add stuff up, it definitely went that way. So that's a /26. That's going to make our first address a 129, and it's going to make our broadcast one below that, so a 191. So now we're starting at 192, and we need to fit in 32 hosts. Well, 32 hosts means 32 hosts, so we have to fit into, so 32 hosts, we're subnetting down to, it's a /27. So 32 becomes our magic number. That's also why I wrote the numbers like that, so to make it easy. So 192 plus 32, and that's going to bring us to 224 /27. Our first host is going to be 193. Our next is going to be, for our broadcast, is going to be the one below, and that's going to be 223. Perfect. This works so much easier when you're fully awake. 24. And this one, we need to give it 8. So that means we're going to have to shift over a little bit. So to have 8 available, that means that our magic number, yep, is the 8. So /29. Easy enough. So that's a /29. Adding 8 to 224. That brings us to 232. Yes. 232. Our first address is going to be 225. Our broadcast is going to be 231. Okay, number 4. We are starting at 232. And it's going to extend to the next network, which is 240, because it's also going to get 8, so that's a /29. First address is going to be 233. Last is going to be 239. HVAC is going to start at 248. It's going to go till did I make a mistake again? Oh my goodness. No, that one's right. 224. 6 is 32, is 8 is that. It's 240. Oh, I see what I did. That's 240, and this extends to 248, and that's a /29. See that? I was trying to jump ahead. 241 is our first. The last on there is going to be 247. Okay, and last and not least, 248, and we're going to bring that up by 4 to 252. And that's a /30 because it's a point-to-point link. So we have only 2 addresses available. 249 to 251 is going to be our broadcast. So now we can kind of fill in our chart easily. It's going to be a lot more easier. So this, if we go ahead, is 192.168, and it is a /26. 192.168.33.192, and that is a /27. 192.168.33.224 /29. 192.168.33.232. 29. 192.168.33.240 /29. 2.168.33.2 248/30. So for the first available host, I'm unfortunately just going to have to transfer those dots here because I can't write the full address out. I just don't have the space. I'm actually going to use a different color to make it where they don't blend together. Let's go now with a nice Jaspire green. So the first available host is actually 129. The first available host is 193. The first available host on this one is 225. First available host is 233. First available host is 241. First available host is 249. And then the broadcast is 191. This broadcast is the last address. And basically we can just sort of peek at the one afterwards. So that's going to be 223. And this is going to be 231. And this one is going to be 239. 247. And this one is going to be 251. And we do end up actually with extra space, so we have enough room for actually 2 links. Because this is 251, the next one is 252, if we had another one, as an example. So this would be 192.168.33.248/30, and we have just enough space if we wanted one more serial link as an example. So that would be the network portion. Oh, sorry, no, that's a mistake. Not 240, it would be 252/30. The first available address would be 253. Then the second address would be 254, and the last one would be 255 as the broadcast address. But we don't have that, so I think that actually comes up in a question. So let's just take that out. So that's where it leaves us, basically. So in the end, we have actually, once we remove our subnet, our actual network address and our broadcast, we actually have 62. We actually have 30. Then we actually have 6. We actually have 6. We actually have 6. And we actually have 2. So that's what we got to work with. So it asks us how many host addresses are available in the /25 network. Well, we just come up here, we zoom into our trusty dusty cheater table that we made at the beginning. So we have a /25. So how many possible addresses do we have? Well, that's our answer right there, 126. Because remember, we basically lose 2 addresses. So we have that formula, 2 to the n minus 2. What is the total number of hosts addresses required for this topology diagram? Well, you'd have to break out your calculator. I guess I can do that quickly. +40 +2 +25 +5 +4 +4. 42, 25, 5, 4, 4. Oh, wait, what did I? Where did I get 76? 40 +2 +25 +5 +4 +4. Okay, that looks better. 40 plus 2 plus 25 plus 5 plus 4 plus 4. So we need 80 addresses. Okay. How many subnets are needed for this network topology? Well, we already kind of went through that. We needed 1, 2, 3, 4, 5, 6. Determine the largest subnet. The largest subnet is going to be whatever BR stands for, Baskin Robin 1 LAN. They're going to need the largest amount, which is, they need 40, but we have to give them 62 because 2 of them get lost. How many IP addresses are required for this? Well, we were required to give 62, however, it only needs 40. What is a subnet mask that supports, what subnet mask can support that many host addresses? It's a /26. So /26, if we look back up at our nifty-difty chart, if we provide a /26, then that means that we have our 62 available hosts. So that's fine there. How many hosts can this address support? Okay, so say it supports 62. Can you subnet the 192.168.33.128.25 network to support this subnet? Yes. What is the network address that would be resulting from this subnet? You know, these are what bizarre questions to ask. I'm just going to bring this over here so I can just discuss them. And yeah, I say they're bizarre questions because, like, if you just subnetted all this stuff out, it's kind of weird to be asking people about, you know, can you or can you not do this and stuff like that. But basically, if you subnetted out the 128 with a /26, you effectively end up with 2 subnets, right? Because you're splitting that 128 by 264 subnets. What are the network addresses that will result from this? You're going to end up with a 128, and then you add 64, and you're going to end up with a 192. So it's basically the 2 networks that you get out of that. And yes, first network for this. Yeah, this is just, I don't know why that's telling us that, but anyways. Determine the second. Oh, yeah. Okay, so basically, I guess technically going through these steps probably would have been a better answer than going through the table first. Oh well. Determine the second largest subnet. Second largest subnet is going to be the other LAN, and the other LAN required the 25. So we can see that if we scroll back up here, B Baskin Robbins 2 LAN, it requires 25. Where is the questions? Second largest. Okay. What subnet mask can support this many hosts? Well, we already talked about that. It was a /27. And if you were looking at the subnet mask, /27 is a 224. And it provides us with 30. And can you subnet this? Yes, most certainly can. So what ends up happening is our 192, now instead of being a 64 block of digits, we get broken down into 232 bits, or 232 host addresses. So the first one starts at 192. The second one is going to end up starting at 224, and they're both going to be /27s. And that one specifically is going to get broken down into our other networks that are available to us. So the next question was asking about what our third largest is. And technically our third largest required anyways is going to be the IoT LAN. But technically the IoT LAN, the CCTV, and the HVAC all require in the end the same size. But in terms of the requirements, IoT LAN is going to be the third largest subnet. And that's going to require 5, so we're going to use a /29. So that's going to be a subnet mask of 248. It's going to allow us to have 6, because if we take over from this portion onward for our subnet, then we end up with 6 remaining. And if we break that down, pretty much that 32 now gets broken down into 4 groupings of 6. Or 4 groupings of 8 technically, because remember we each have 8, but what's available to us is 6. So our first one's going to start at our 224, our second one is going to start at 232, the third is going to start at 240, and the fourth is going to start at 248. So 3 of those are going to end up being used, and the fourth one, the one that starts at 248 that we've already discussed, that one's going to be broken down. So 248 is where our link between the 2 routers is. So our 4th largest subnet, I know in the instructions, or in the reference rather, it also says that this would be this specific link here, but technically, it's not really our 4th largest. Our 4th largest would actually technically be CCTV and HVAC tied. However, those 2 have already been assigned, because it says that the first is going to be used for the IoT. It says the second one of these is CCTV, and the third is HVAC. So all that we have left is the last link. So that's kind of why it makes sense, I guess, that it's the 4th largest subnet. It requires only 2 addresses, so we have to give it 4 because we need our broadcast and our network. It's going to be a /30. It's always a great thing to remember. A /30 is always what you're going to use on these little point-to-point portions that are going to require 1 on each side. And you can subnet it twice, basically, the remaining space. So we can subnet those that 8 block into 2 4 blocks, and that's what we're effectively doing. So with that, let's go ahead and let's go ahead and configure this. So I'm going to grab this and chuck this over here. I'm going to throw my tab away so I can actually type on the keyboard easier. And since the last one, I actually went ahead and I even made this bigger, so it makes it a little bit easier for those of you on smaller screens to see. Okay, so on the instructions, it tells us we need 2 routers. They're going to be 4331, so uno and dos. And we're going to add our switches. They're going to be 2 2960s. Nice, fun little switches to chuck in there. Perfecto. What we're going to do now is we're actually going to go ahead and I'm going to check in. Yeah, that's fine. I'm going to check in a display name while we're waiting for this thing to start up. So BR1 and 4331. BR1, and this one is BR2, and switch over here is going to be S2, and this one is going to be S1. So in here, what we're going to end up doing, I'm going to grab our trusty dusty copper straight through. We're going to connect fast Ethernet 5 to gigabit Ethernet 01. And I know it says to use a straight through, but I am going to argue and say that, following the quote-unquote proper process. It really should be a crossover. Yes, it has auto-sensing, but pretending that it doesn't, we're going to make it work like that. You'll notice all the links are down, and the reason why they're all down is because on these routers, their interfaces do not come online automatically, even though the switch side does. The router does not, therefore the link will not come online until we bring those interfaces online. So next up, we're going to go ahead and we're going to configure our routers. So on BR1, we're going to drop into our CLI. If it ever asks you about this whole initial configuration dialog, you're always hitting no to that and pressing enter. We're going to go into our enable mode. Inside of enable mode, we're going to go into global configuration mode. So config T. Inside of configuration, we're going to set our host name to BR1. All right. And we're going to help ourselves out by putting in this no IP domain lookup. That's what I missed on. So we're going to do that, and I'm going to show you what the whole purpose behind that is. So if I go over here, and I'm in here, and I type in something like that, you'll see how it says the translating to domain server. It's not going to be able to find anything. But that's what's basically going to happen. Now, by placing that command, if I go back and I type in, it basically just says, sorry, Charlie, and kicks you back because it doesn't know anything about it. So while that one thinks about what it's done with its day, let's go back to our configuration terminal. We're going to enable secret of spelled secret wrong. I got a secret and I can't spell secret. Enable secret class. We're going to configure our line console, so line con 0. We're going to go set our password to Cisco. We're going to tell it to utilize that password with the command login. And then we're going to go ahead and do line VTY 0 4. And interestingly enough, I think I mentioned this before, the 04 means that we're actually only allowing 5 connections to the router. But the same thing, we're going to go ahead and do our password Cisco login. So we're setting that up. And we're going to do our service password. Oh, we're in the wrong mode anyways. So let's back out. Service password encryption. There we go. We're now going to utilize our banner MOTD $unauthorized access is prohibited. Gotta love the message of the day. Alright, and before we get too far, let's go and finish up the other one. It should have thought about its day. Yep, perfect. It's very happy now. Cool. Config T. Another little nifty trick as well that you can do is you can also toggle back and forth sometimes the simulation real time to sort of speed that up if it's stuck in a reading loop. But now we can go ahead and do our host name BR2, no IP domain lookup, and then we're going to see if I can spell secret this time, and we did that well. We're going to also configure our line console 0, password Cisco, login to use that, our VTY 0 through 4, password Cisco, login. Going to go back. Service password encryption to basically encrypt our passwords. We're also going to do our banner MOTD $unauthorized access is spell wrong. Oh well, it's just a banner. Okay. So now that that's done, we need to now configure our interfaces. So basically, we can go back up to our little table of hours. And our zeros, the triple zeros, are going to be facing each other. And the double zeros and ones are going to be facing outbound. So what we're going to end up doing here is we're going to go ahead and do our interface giga. We're going to do our triple zeros first. So IP address 192.168.33.249. And our subnet mask. Unfortunately, you got to type it in fully like that. And then we can do our description. And then our no shutdown. Interface giga 001. The address 192.168.33.129. 255.255.255.255.19. Oh, one too many 255s. 3 octets of 255.192. That gives us our 40 host VLAN. So I said VLAN, but LAN, same thing basically for this. Description 40 host LAN, no shutdown. Okay. Oh, did I just did that. Well, isn't that exciting? See, I just configured these the wrong way. The description, I'm on BR2, not BR1. Easy enough to fix. It's a 25 host VLAN, and instead of being 129, 33, it's 193. 255.255.224. See, easy enough to fix that. And then let's go fix our other interface. This one is actually easier because it's just the wrong address. Like that. And then we go out here, show IP interface brief. Check out our fun tables. If they're a little bit crowded, just drag it over. So we have 192.168.33.250. That's BR2, yes. And our other one, that's correct. If you want to see the description, you actually have to do show IP interface, and then you can actually get your description information, if I recall correctly. Does it actually show? I actually don't even remember where it shows the description, to be quite honest. Oh well, not really important for this particular lab. But anyways, obviously if you show, running config, you can see the description. I guess that's probably where it's actually useful. But other than that, so let's go ahead and configure our addresses here. So we're going to go to our giga triple zeros, and we're going to configure our IP address 192.168.33.249, 255.252. We're also going to turn on our description, BR1-BR2 link, and we're going to do no shutdown. Bada bing, bada boom. Okay, and now we can go do our other interface. That's facing the VLAN, so Giga 001 IP address 192.168.33.129 actually this time, and 192. Okay, and we're going to do our description of 40 host or 40 host LAN. No shutdown. Help if I spelled it right. There we go. We got our protocol and our line state or link state has been turned online. And if we do an exit, we get back here, show IP interface brief. We can see our status is up and up, which is solid. You can see the difference being administratively down. If we look here, we'll see that they're slowly starting to make their way online. It does ask us to do a copy running config, startup config. So sure, let's go ahead and do that then. So copy run start. Basically, we're just saving our configuration. Copy run start. Perfect. Brief. Make sure I set these ones right since I made the mistake and I corrected it before, but I just want to verify. 193, yep. Up, up, up. Perfecto. So on this one, the last step it asks us to do is to go ahead and ping to the other side, but we're just pinging across the actual link itself. So we can do a ping of 192.168.33. This is BR1, so 250 would be the other side. We're going to probably time out one, and then the rest are going to go through. And we run it a second time, and success all the way through. Remembering that because it is Ethernet, it needs to build that cache table to determine where the address actually is. 168.33.249. Perfecto. All right. So in the end, that's actually the end of this particular lab. So I'm just going to go through some common mistakes and things to watch out for if you happen to make those mistakes anyways. Or we can test out some things. So if we go back into configuration mode and we go into our gigabit Ethernet, so Giga 000s, and instead I actually, like I said, I made that mistake originally. So let's see what happens if we keep that mistake. IP address 192.168.33.249. 2522225. Yeah, see. Basically, it throws that error, and I'm curious, did it actually still set it, and it's just broken? Show IP. Oh, went back one. Show IP interface brief. Oh, it did actually allow it, but it's telling us that it did find a duplicate at the same time. Interestingly enough. Let me just see one other thing. Config T interface Giga 000s. We're going to do a shutdown. I'm just going to say no shutdown and just see if it actually will bring the interface online. Like, obviously it's cranky. It's saying that, it's able to find another device with the same stuff. Show IP interface brief. Yeah, but it's just basically, it's angry. And I'm pretty sure if we probably tried sending traffic across it, or at least trying to get across the way, like, I'm actually curious, 192.33. What it would end up happening. It says it gave you a round trip, but who knows if it's actually pinging itself or it's pinging the other side. But it does give you that error that says you do have a duplicate. So that's kind of nice to know, though. So config T interface 000s. Let's go fix that back up again. IP address 192.168.33.250, and it's a /30, so 252. And let's go back and check it out. Show IP interface brief. Help if I spell brief right. There we go. So now that's all corrected up. And same thing, we can run our previous ping, and hopefully this will go through. First one fails because now, so last time it was most certainly probably just pinging ourselves. The fact that it did fail when we had to redo it again. So yeah, so that's kind of one place probably where you would make a mistake. I don't see really anything else. You know, obviously if you're looking at this, you want to make sure that you have, you know, as I click on that, you want to make sure you have up and up basically. So green and green, green and green, green and green. You can send your data, and I think if I recall correctly, if we try to send a PDU from here to here, does not have any functional port. Oh, that's right. It's not going to be able to actually send anything because there's no VLAN associated. So you can't actually address anything off these switches. That was the other thing I wanted to talk about. So the lab is officially done, but if we want this to, you know, be a little bit more exciting, we can actually use our found knowledge to set up our switches. So we can actually go into here. Same thing, we can do our host name of S1. Help if I was in configuration mode, that would help, yes. Host name S1. I guess we can also take a look at that no IP domain lookup, so that way we don't have that pop-up that's going to happen. You know, we can do our similar enable secrets, so enable secrets. So I guess there's just too many things that start with, yeah, it's ambiguous. So ambiguous just means you didn't type enough of the command so that it knows what you were trying to tell it to do. Line con 0, password Cisco, login, line VTY04. We're going to just configure it similar to what the other things were. And login again, so that way it, you know, and actually requests the use of the password. And then it also went ahead and it did the service password encryption, and we did our banner MOTD $unauthorized access is prohibited. Perfect. So that's all it did there. Now, what we're actually going to do, like I said before, this is beyond the lab. We're just going to have a little bit of fun here. So on S1, we're going to give it an IP address as part of those hosts, right? And what address did they give it for this router? $129. So it gave it the first available IP address. So why don't we give it the second address then, or we can give it a different address. I don't really care. It doesn't really make a difference. Like I said, it's not really part of the lab. So let's just give it them all the second address that's available. So we're going to do our interface VLAN 1 and our interface VLAN 1. We're going to go 192 or IP address 192.168.33.130. It's not going to be 129 because 129 is already being used. 255, and if I recall, it was a 192 because we're giving it 64. Checking on my notes, it is indeed a 192. We do the node shutdown. Perfect. Show IP interface brief. We have our interfaces all there. And there we go. We got our VLAN 1 is now up and up. So if we show our VLAN, we can see how all of the interfaces are currently assigned to the default VLAN of 1. And so we can close that now. Let's go over here. Go to the trusty dusty CLI. enable config t, and then from inside of here, we're going to go ahead and set our host name to S2. And then we're going to go ahead and enable our secret of class. Spelled secret wrong again. Secret class, line console 0, password is Cisco, login, line VTY04, password Cisco, login. We're going to kick ourselves out. We're going to do service, password, encryption. Then we're going to go ahead and we're going to configure our banner message of the day, banner MOTD, $, unauthorized, access is prohibited, $. Fantastic. I think that's everything except for our IP bit, and we can do that part now. So interface, VLAN 1, IP address. This one is S2. S2 is going to be using BR2 is 25 hosts. Okay, and BR2 is getting actually 32, so that's 224. So 192.168.33.193. Well, we can't use 193, so we got to use actually 194. 224, no shutdown. Cool. Now we can do a little bit of playing around now that we have some interfaces up. So on S2, we can go now to our enable mode and we can run a ping. We can say ping 192.168.33.130. And obviously it's not going to go through. And we'll see it not go through in a second. Exactly. Doesn't go through, which is fine, right? But, you know, this is S2. Why don't we try moving back a bit? So before I was trying to ping this S1. Why don't we try trying to ping the interface instead? So now we're going to try to ping BR1's outside interface. It's also going to fail. Same reason why. It doesn't know how to get there. Why doesn't it know how to get there? Because, you know, we also haven't even configured our default gateway either, so that's really not going to work out too well for us. There's a few things that we're missing, actually. But even if we went to, like, BR2 and we tried to ping, you know, S1 as an example. (192.33). S1 is sitting on the 40 host, so that's 130, 255, 255, 255, 192. Oh, we don't actually need to. Why did I put the mask? But it will still fail, regardless. It doesn't know how to get there. Exactly. It fails. If we do our show IP route, what we see is we can see our locally, you know, connections. So our local connection being the fact that we can see this side and we can see this side. Because this side of the network is on an entirely different network, we can't see anything. So we can kind of correct this if we really wanted to. And the way we'd do this is if we went to configuration terminal, and from here we can do a static route. So let's just see. There we go. So basically IP route, we have our destination, where are we trying to get to, what network. So our destination network we're trying to get to from BR2 is 192.168. This is 33 dot, the network is 128, do a space. Now it's going to ask us for our subnet mask, so 255.255.255.192, and then we do a question mark again. Remember, we can do this sort of to, gauge out what's happening. And now it's asking us, what do we do? So you can either specify the forwarder address, as in what is the next hop's IP address, so that being, the inside of BR1, or we can specify the physical interface that we're going to forward this out. That part, I don't know necessarily if there's going to be a big difference on the speed. Can we default route without gateway? If not, point-to-point interface may impact performance. Yeah, so it is a point-to-point interface, so we don't have to worry about that. And basically it's saying that if you weren't directly sending it to another thing, by just saying send it out this interface, it may not go to where you expect it to go. Now to get the traffic back, what we're going to do is on our BR1, we're going to do something just slightly different. Instead of configuring it as the interface to forward it out, we're going to configure it as the next hop's IP address. So we're going to do our IP route for our other network. So 192.168.33.192. Yes, for our 25 hosts. 255.255.255.224. And when it asks for our next, we're going to give the IP address of BR2's inside interface. So it's basically the forwarding router's IP address. So 192.168.33.250. Okay. So we do our show IP route. We now see that we actually have a static entry in here. It's basically considered, probably, from what I recall, it's going to be a high priority based route because it is a statically configured one. So what ends up happening is we have our 192.168.33.0, and it basically looks at the class full. It says, hey, I know about 5 different subnets that are basically connected here right now. So that being, it sees that we have 128, that's a /26. It's looking at the locally connected on the other, the outside interface, basically. I don't know why it says it's /22 or /32 rather. Oh, it's just saying that's what the IP address is. That's what that is. It's saying that's what the IP address is that, and that's what the IP address of that. And then it also says that the directly connected, that being the 248, is the interface between those two. So now, if I go ahead and I try to ping something, so 192.168.33.194, if I recall correctly, is the interface. Let's see if we fix the problem. Still may have something broken. No, it still fails. Am I just bad at addressing? Did I misconfigure something? Possibly all of the above. Yeah, that didn't go through. Okay, so let's take a gander and see what's happening. Show IP interface brief. $33,194, that is correct. I guess I should still configure my default. That's actually probably what it is. It's probably that the default gateway is not configured. So it's really not sure how to get its way back to the process. Okay, so what we can do is we can go ahead and configure that then. So in global configuration mode, we can go ahead and do IP default. Oh, I spelled IP wrong. IP default gateway 192.168.33.193. And let's go over to this one. Cisco enable class and configuration terminal. IP default gateway 192.168.33. Geez, what was the IP? 129. Okay, let's try doing some tests now. See where we break. 192.168.33.193. Can we ping that? Perfect. Okay, so now we can move on to our next network. So our next network, can we ping? Let me get back my... We are going to try to see if we can hit the point-to-point link between the two Bs. So for that one, between the two Bs, that's going to be 250. See, that now works. Now let's hit the interface on BR1. See, that one works. Perfect. Now let's go ahead and hit the interface on the other side of BR1. So on the other side of BR1, the interface is 129. Come on. There we go. Perfect. So it's got its way there. It built its information. And now let's see. Do we have a working system between the two of these? Oh, there we go. It just took a little second to build some stuff. So there we go. So switch 2 is now able to ping switch 1's interface. And let's come over here. And can we ping the other way around? 133, I sure hope so. And 194. There we go. We got connectivity between our two switches from switch 1 to switch 2. So obviously that's, well beyond the scope of this lab. And if we do our show IP route, as I said before, we have our static entry there. The next point that we've labeled off is the hop, which is BR2's interface. If we come over here, we can do our show IP route, and we see the same thing. We have our 250. That's the interface's IP address. That's why it's a /32. We have our /30, so it's 248 is the network that it sits on. It knows about. We also know that the 193 is the outside facing. We have that, and then we have our static entry in there. So to get to the 128 network, which is a /26, it has to basically send it out. And you'll notice that it doesn't have that next hop IP address. Instead, it's just saying that the next point is just forward out this interface and call it a day. So in this case here, these two are directly linked point to point, as you saw there. And see how the difference is between the two static routes. This one here is static, and it has the next hop. This one here is static, and it just basically goes to the next interface there. You'll also notice that it doesn't have the same cost method, so it's not applying the same cost. This one actually has a cost attached to it, whereas this one is just applying it as if it's a directly connected network. It just needs to forward it out that particular interface. So yeah, that's really all we can probably apply and do on this that we would know. if we wanted to get into, more complex stuff, basically we could come over to BR2 and we could start dealing with sub-interfaces, but that's also beyond the scope of what we've talked about in the course anyways. And sub-interfaces basically allows us to have multiple different networks facing off of this BR2. So if my memory serves me correctly, if we were doing sub-interfaces, so in this case here we have our Giga 001, what would end up happening is we would have something like interface G001.1, and then that would create a sub-interface, and then we could go in there and attach an IP address to it, etc. But let's not do that and say we did, because now I think it's just going to add it in there. Show IP interface brief. Did it add the sub? Yeah, it adds the sub interface in there. That's terrible. But I can just simply restart it because I've already saved all my settings anyways. But yeah. So hopefully you enjoyed the lab and you enjoyed the extra little bit there. Yeah, hopefully it's all successful for you. And take care and have a good rest of the evening.